So I got a question about binomial probabilities and how to do the kind of questions where you have to do 1 minus something. So I'm going to start from the beginning with binomial probabilities and kind of go through all the different types of problems. So firstly, remember that a binomial probability is when we know the probability of something happening one time or just overall, and we want to know what is the probability of it happening a certain number of times. So in this example, a die is weighted so that the probability of rolling a 6 is 0.48. So we know that the overall probability of rolling a 6 is 0.48, and then we know that we're rolling the dice 18 times. So on part A, I want to find the probability that it lands on 6 exactly 11 times. So usually when we set up a binomial, we kind of write out, okay, this is binomial, n would be the total number of trials, p is the probability of it happening just overall or once, and we want to know about x, which is the number of times we roll a 6 out of 18. In this problem we want what's the probability that x is exactly 11. Now if you look on the formula chart, the formula we use for this is we say n choose k, so 18 choose 11, p to the k, so we want it to happen 11 times, and then 1 minus p to the n minus k, which is 7. So we want it to happen 11 times, not happen 7 times. And you can use that formula to find the answer, but if I want to do it with a calculator, I'm going to go to second vars, and then at the bottom we're going to use binomcdf. And we want an exactly, this time we want exactly 11 times, we use binomcdf. And then my calculator is older. If you have a newer one, it'll bring up a menu and tell you what exactly it wants, but the three things it needs are n, p, and x. So I'm going to write my n is 18, and then comma. If you have a newer calculator, you don't have to put the commas, just type in the three numbers. P is next, which is 0.48, and then x, which is the number of times we want it to happen, so 11, and that is our probability. So the probability of it happening exactly 11 times is 0.102, we'll say. So then I'm going to scroll down a little bit, find the probability that the die lands on a 6 no more than 5 times. So that means we want the probability that x is less than or equal to 5. So same x, same n, same p as up there, like defined x. But this time I would have to do, 18 choose 0, 0.48 to the 0, 0.52 to the 18th, all the way up to 18 choose 5, 0.48 to the 5, 0.52 to the 13. And I would have to do that individually. And even if I wanted to use binomcdf, I would have to do that individually for 0, 1, 2, 3, 4, and 5, and then add them all together. Our calculator is designed in such a way that lazy people have a quicker way to do things. So binomcdf is for lazy people like us when we don't want to do all of those individual things and add them together. So what we're going to do is go to binomcdf. Binomcdf is when we want less than or equal to, which is what we want here. So less than or equal to a 5. It takes the same three things, so n, comma, p, and then x is what we want it to go up to. So we want less than or equal to 5, so I'm going to put a 5 there, and when I use binomcdf, it will do everything less than or equal to 5 and add them all together for us. So second vars, binomcdf, 18, 0.48, and 5. So then we have our answer, 0.0676 is that answer. So then the actual question that the person asked is what happens when we want at least 4 times. So probability that x is greater than or equal to 4 would mean 4, 5, 6, 7, 8, 9, 10, all the way up to 18. So as you can imagine, using the formula or even using binomcdf for all of that can get really tedious. We like shortcuts, but the problem here is that the shortcut is only for less than or equal to. I don't have a shortcut on my calculator for greater than or equal to. Okay, so what we're going to do is figure out what we don't want, which is the stuff less than or equal to 3. We want greater than or equal to 4, so we're going to find what is less than or equal to 3 in our calculator using binomcdf. So second bars, binomcdf, again 18.48 and then 4, and that is 0.0233. That's everything we don't want, that's less than or equal to 3, and then if we do 1 minus that, that will leave us with everything greater than or equal to 4. Which is 0.9767. So that is our probability that the die lands on 6 at least 4 times.